So today is the last day of our review for our end of course exam, all right? So to evaluate the square root of 25 over 36, I must take the square root of the numerator and denominator. What's the square root of 25? What's the square root of 36? And I just write it into a fraction. The same thing goes with the cubed root. What number can be multiplied by itself 3 times to equal 27? 3. And what about 125? So it's 3/5. 3/5. To approximate the square root of 3, you are allowed to use your calculator to get to 1.7 and to plot it on a number line. The dot would just go right after the 1.5, or if you went, by ones, it would just go, right between the 1 and the 2. All right, now on 54, Anthony, what is step 1 to solve that equation on 54? Yes, subtract 25 from both sides, and 3x squared equals 75. Lily, what do I do next?
You divide by 3.
Divide by 3. And Caitlin, what do I do last?
You square it.
I square root. All right, now on 55, oh, wait. On 54, did you put positive, negative? Okay, so when you solve an equation with the square root, not cubed root, but with the square root, your answer can be both, because negative 5 times negative 5 is still 25. All right, so for 55 and 56, all right, what do you notice that is similar about both of those figures?
They're triangles.
They're triangles, and more specifically, what kind of triangles?
Right triangles.
What tells you that it's a right triangle? It has the box for the right angle. So because it's a right triangle, does anybody remember what formula I can use to solve for the unknown side?
A squared plus B squared.
Yes, very good. So that's going to be true on 55 and 56. Go ahead and finish both problems using the Pythagorean Theorem. Okay, Pythagorean Theorem. Did you put a squared plus 9.6 squared equals 10.4. That should be a square. Then evaluate your squares. Subtract. And is it looking like it's going to be an even number? No, not with these decimals. But somehow it does subtract out. And when I square root it, I get 4 meters. Who got 4 meters? Anybody get 4 meters? All right, now on slant height, guys, slant height almost throws you off, okay? You think, slant height, like what's going on here? It's still a right triangle. Inside this pyramid, it's forming a right triangle. So I still go a squared plus b squared equals c squared. And then I can square root both sides after I evaluate, and I get 2 centimeters. 2 centimeters. All right, any questions? All right, Pythagorean Theorem. Let's move on to number 57. On 57, it initially appears to be pretty easy because it just says approximate it to the nearest tenth. Okay, so we are going to follow those instructions. Pay attention. We are going to follow those instructions. Well, to approximate it to the nearest tenth would just be 0.9. 0.9. All right, but I'm going to take it a step further because I think this is a good opportunity for us to review converting a repeating decimal to a fraction, just in case that were to come up. So to convert a repeating decimal to a fraction, does anybody remember what I do first? Mason. Okay, put it into an equation. Okay, x equals 0.86, repeating, and then what do I multiply it by? So he just said it. What do I multiply it by? 100, because there are 2 repeating digits. 100x equals 86.86 repeating, but I still have my repeating symbol. The next step eliminates it. Go ahead and try to write the next step. What did you subtract? X equals 0.86 repeating. All right, and then divide both sides by 99, and it doesn't reduce. You just leave it, 86 over 99. Okay, all right, let's go ahead and start working on number 58. Right, so 36 squared plus 60 squared equals 70 squared. Is that true? Well, 36 squared plus 60 squared is 4896. So if the other side is 4896, then I'm good to go. Is 70 squared, what is it? 4900. Not equal. Not equal. All right, so we're not going to do 60 and 62. If you've already done it, I'll definitely check them. But just for the sake of time, we're going to focus on these last two problems. They are more relevant for your EOC, all right? And they have to do with a cone. And solve number 59. Plug in your numbers. You have to know the formula. Once you have the answer, raise your hand. I want to come check. All right, so I plugged in 1/3 pi r squared h. And wait a second, where did I get the 6 from? Did I make a mistake there? I don't see a 6 in the original problem. Okay, but 12 is the diameter, and I have to plug in for radius. Now, remember, you have to show some work here, so I want to see what number you're taking 1/3 of, and that's 1695.6. And how do we say we can do this without using the fraction button? Divide by 3. Divide by 3. That's important. We've got to get away from that fraction button. Okay? Don't use it. All right? And then that's going to be meters to the 3rd power. Number 61. Number 61 gives us volume that we plug in for volume. And then again, it's 1/3 times pi, but now I don't know the radius. So what can I do here to start unpacking this problem and simplifying what's on the right side of the equation? Can anybody tell me what would I do here? Ethan, what did you do on number 61 to start simplifying the right side? Yes, multiply 3.14 times 9 and then divide that number by 3. And that's how we get the 9.42 r squared. And now, Eric, what am I going to do to both sides? What would I do to both sides? Yes, divide by 9.42. And Jace, what's my last step? Oops, I gave it away. Yes, you have to do the square root. Is my answer positive and negative? Why? It's a measurement. Yeah, very good. Okay, awesome, guys. That's a great job, and that wraps up our review.